Okay, so you are welcome to the example 2 of the calculations under DC circuit. And the question is, for the figure below, calculate the following: I, total resistance, II, circuit current, III, total power, IV, power in each resistance, and then V, voltage across each resistor. So that is the diagram that the question is talking about. 3 resistors that has been connected in series. Okay, 3 resistors that has been connected in series across a voltage of 28 volts. Okay, all right, so let's name the resistors. So we have R1, R2, R3. But before we start with the solution, please make sure you subscribe to the channel and then share the videos. Okay, all right, thank you so much. So let's move on with the solution. So we have to calculate I, that is the total resistance. Okay, and we have 3 resistors that has been connected in series. So to calculate for the total resistance, which is the RT, what we do is we add all the resistors together because it's a series network. Okay, so RT is equal to R1 plus R2 plus R3. Okay, so we have 6 plus 3 plus 5, and when you add 6 plus 3 plus 5, we are going to get what? 14 ohms. So the total resistance RT is equal to what? 14 ohms. I hope you understand. Okay, so let's move on. II, which is the total current, and by Ohm's law we know that current is proportional to voltage and then inversely proportional to the resistance. Okay, that is Ohm's law. So IT is equal to what? VT over RT. That is the supply current, or the total current, is equal to the total voltage divided by the total resistance. I hope you understand. Okay, so we have 28, which is the total voltage, over the total resistance, which is what? 14. So when you divide 28 by 14, we are going to get what? 2 amps as our total current. Okay, so let's move on with solution III, which says that we should calculate for the total power. So because the circuit is a series circuit, it means the current is common. Okay, so that means the current that is flowing through resistor R1 is the same current that flows through resistor R2, and is the same current that flows through resistor R3, and is the same as the supply current or the total current. I hope you are following it. So we say IT, which is the supply current, is equal to I1 is equal to I2 equals I3, which is equal to what? 2 amps. I hope you understand. Okay, so the total power, which is what? PT, is equal to VT, which is the total voltage, multiplying by IT, which is the total current. So the total voltage is what? 28, multiplied by 2, which is the supply current or the total current. And when we multiply 28 by 2, we are going to get what? 56 watts. I hope you are following the steps. Okay, so let's move on to the solution IV, which is the power across each resistor. That is P1, P2, and then P3. P1 being the power across resistor R1, P2 power across resistor R2, and then P3 power across resistor R3. I hope you are following it. Okay, So P1 equals I square R1. Okay, I is the current, that is the supply current or the total current or the current that flows through R1, because it's a series network, so the current is what? Common. I hope you are following it. Okay, so we have 2 squared multiplying R1, which is what? 6, and 2 squared times 6 will give us what? 24 watts. I hope you understand. P2 equals I square R2. So we still have 2 square, that is the current square, times 3, which will also give us 12 watts. Then P3 also equals I square R3, which is equal to 2 square multiplying 5, and that one also will give us 20 watts. So to calculate for the power across each resistor, P1 is what? 24 watts, P2 is what? 12 watts, and then P3 is what? 20 watts. Okay, so we move on to solution V, which says we should calculate the voltage across each resistor. Voltage across each resistor. Okay, so V1, that is the voltage across resistor R1, and we use the formula I1 multiplying R1. Okay, so I1 is what? 2 times R1 is 6. So when you multiply 2 by 6, we are going to get what? 12 volts. V2, that is the voltage across R2. That one is also I2 multiplying R2. So we have 2 multiplying 3, and when we multiply 2 by 3, we are going to get what? 6 volts. And then V3, which is equal to I3 multiplying R3. So I3 is what? 2 multiplying R3, which is 5. So 2 times 5 will give us what? 10 volts. Thank you so much for watching.